Hey guys, so tonight we're going to be talking about the scientific revolution. This begins our unit for unit number 6. This is our first video. You can see the full SOL below. Unit 6 is a huge unit, so we're going to be covering a lot. But tonight is just the scientific revolution and the people who are important to it. So let's get started. First, what was the scientific revolution? It was a new way of thinking. It started around 1500 and lasted until about the 1700s. And it was a new way of thinking about the natural world, the world around us. And it was a big change from the traditional way or the old way of thinking about the world. It was based in reason and logic and observation, whereas previously people understood the world around them often through religion. You kind of got a taste of that when we talked about the Renaissance and the Reformation and how people relied on the church and religion to tell them how the world around them worked and why things were the way they were. There are also some taboos about the way you study the natural world. Like people couldn't study the human body the way they wanted to. It was taboo to cut open a human body after someone was dead, so it wasn't done, and people didn't understand exactly how the human body worked. The first people who studied the body had to do so on animals like pigs, and they tried to understand. They thought that the way those animals worked was the way that humans would work too. So this was a new way of thinking about the world around us, about the natural world. And it was encouraged by the Age of Exploration. So during the Age of Exploration, these explorers are going out, people are encountering new things, new people, and making them question and think about the way the world works. So these new encounters with new places and new people, new experiences are making people question and look to reason and logic to explain these things. And there was a need for new knowledge with people exploring. There was a need for better understanding of astronomy and navigation and geography and mathematics, and this need for new knowledge so that people could explore and go further and see these new places and do these new things meant that people were studying, and they're trying to figure out these better technologies and these new ideas and understand the world around them. And so it really encouraged the scientific revolution. So let's go ahead and talk about some of the people of the scientific revolution. So first is Nicholas Copernicus. I've given you dates for each one of these people we're going to talk about. That date is when they either published their work or when they made their discovery or when it became known to the rest of the world. So Nicholas Copernicus, he comes up with a heliocentric theory, which means that the Earth is actually revolving around the sun. The church, the Catholic Church, prior to Nicholas Copernicus and his discovery, believed that the Earth was the center of the universe and that the sun and the moon and everything else revolved around the Earth because God had created the Earth as a special place in the center of the universe. Well, Nicholas Copernicus is looking at the planets, looking at the stars, studying how things are actually happening in the natural world, and realizes that this isn't true, that actually everything in our universe is revolving around the sun. The sun is the center of our universe. He's the first person to come up with this. And obviously that is contrary to the church doctrine, and it's kind of upsetting to some of the people of the church. So his work was called On the Revolution of the Heavenly Bodies, and because he was going against church teaching and tradition, he actually didn't publish his work until he was essentially on his deathbed. He publishes his work the year he dies. It's given to him, published on his deathbed, essentially when he's about to die, maybe not exactly on his deathbed, but he holds back his work because he knew it was going to be controversial. So that's Nicholas Copernicus. Next is Johannes Kepler. His important work or his discovery was made in 1601. He was a mathematician who studied actually his mentor's works. And from studying his mentor's works and his mentor's observations, he realizes that the planets revolve around the sun in an elliptical orbit, not just a circle, but in an elliptical orbit. So this is also important. It makes a huge difference in times of the years, things like that. And so this is a big discovery. So Johannes Kepler, elliptical orbit, and he further confirms the work of Copernicus. So
That's important that he is confirming this previous scientist work and really proving his theories correct too. So next we're going to talk about Galileo. So Galileo's important discoveries happen in or around 1609. Galileo is using a telescope and he's looking at the planets, he's looking at the stars and the moon and everything around us, and he makes some important discoveries. He realizes, one, that the moon's surface is rough. This is big. This is a huge difference. Ancient Greek and Roman understanding was that the stars and the moon are made out of a perfect substance by God, that it's smooth and perfect. Galileo actually discovers that the moon's surface is rough. He also discovers dark spots on the sun, so the sun's not a perfect light. And lastly, that Jupiter has 4 moons. So he found 4 moons for Jupiter. All of these things are kind of groundbreaking and earth-shattering. They're new ideas. And like I said, he uses a telescope to confirm these discoveries and also to confirm, again, Copernicus's initial findings, his initial beliefs. This is important because, again, he's challenging the church's authority. He actually has a bigger running-in with the church, and he claims, he signed a statement saying that his findings aren't true, that the church's teachings are true. That's not really important to us, but it's interesting. And it's also interesting that the church doesn't recognize officially Galileo's findings until 1992, the Catholic Church. Obviously, we knew way before 1992 that his findings were correct, but the Catholic Church doesn't actually go back and correct their official standing on Galileo and his discoveries until 1992. So next we're going to talk about Isaac Newton. Newton's big discovery is in 1687, and Newton has to do with gravity, the law of gravity and of motion. So his biggest thing, he's looking again at the planets and the stars and everything moving in our universe, and he realizes that every object in the universe attracts other objects. And that attraction is different or more intense based on the size of the objects and the distance in between them. So again, that's kind of confusing, but he realizes that all of our objects in the universe are attracted to each other, and that the strength of that attraction is dependent on the size of the objects and their distance to each other. And you think of that attraction like you think of magnets, how magnets have magnetism and they pull towards each other. This begins the law of gravity, that there are actions in our universe that pull on us. So that's what that attraction is referring to, gravity. He also says that all objects in the universe are in motion. That kind of goes along with the orbit that we talked about earlier. So he says that there's the law of gravity, there's these forces in our universe, and everything's attracted to each other, and that everything is in motion. He says that God is a clockmaker. So the way he sees the universe is that God is the clockmaker who set everything in motion. He sets the universe in motion, and that the universe is God's clock. So that is Newton. And last, we're going to talk about William Harvey. Harvey's really basic, really simple for us to know about. His discovery is in 1616, and he discovered how blood circulates in the body. He discovered that the heart pumps blood through our veins and throughout our whole body. His predecessor actually studied pigs and found out that there were valves, like on and off valves in our veins, but he didn't know what they did. So Harvey comes behind him and continues his work and realizes that those valves are to help push blood throughout our body, and that the heart is the organ that really pumps that blood. So that is Harvey. Last, let's talk about the significance of the scientific revolution. First, reason and observation. There is an emphasis on the systematic use of reason and logic to come up with these new ideas and these new discoveries. No longer are we relying on religion to tell us how things work in the universe. We're going to use reason and logic to look around us and figure out how the world works. Last, the scientific method. So you probably know about the scientific method, coming up with a hypothesis to answer a question, identifying variables, using experiments to prove whether your hypothesis is correct or not, collecting data. All of this, the scientific method itself, is created during this period of time. And that's important because it's using reason and logic to come up with these new ideas, actually using experiments and data to drive our understanding of the world. So the scientific method is a logical procedure for gathering and testing ideas, and it is established during this time. It's also important to note with the scientific method that it's using math and tools and experiments. It's not just using religion or relying on what we think might be right based on religion. It's tools and math and experiments. And lastly, the expansion of knowledge. So during this time, we have all of these people studying all these things, and we're expanding our knowledge in so many areas: math, physics, other areas of science, astronomy, anatomy, meteorology, which is weather, how the weather works and affects our world. So there's just this huge expansion of knowledge in all different areas. So that, in a nutshell, is the scientific revolution. We're going to move on to some new topics in Unit 6 tomorrow, specifically absolutism during this age. So I'll see you tomorrow.